No, ma'am. Ma'am, now it's starting.
Okay. So good morning. Last time we did, when we were doing atmosphere, we covered upon the various layers of atmosphere. And in that we talked about the last one, that being the thermosphere. The thermosphere has been divided into two sublayers. The closer one to mesosphere is known as ionosphere, and the far away one is known as exosphere. Clear? Yes. Okay. So now we talked about ionosphere and its layers, where it has some other sub-layers, which are D layer, E layer, and F layer. Clear? Now, in these layers, there we get the signals of different frequency. Like in D layer, we get a low frequency, and the high and medium frequencies are stopped. Yeah. Then in E layer, we get medium and high frequency, and the low frequency is stopped. And in F layer, F1 and F2 are collectively known as Appleton layer. And here the high and medium frequency radio waves are sent back to the Earth. Here, did you get it? This is the layer where the signals of high and medium frequencies are sent back. Yeah. Now, then we talked of exosphere. It is the outermost layer, and we have very little knowledge about it beyond 640 kilometers. After 640 kilometers, we don't know much. We know only that it is mingling with the outer space. Okay. Then the density is very low in this area, and the atmosphere has nebulas, which is highly rarefied, and they are rarefied means they are very thinly, sparsely scattered. Okay. So we did about this last time when we met. Now it's and the atmosphere resembles as a nebula. So the atmosphere in this area, it resembles a nebula because it is highly rarefied. Now, what is a nebula? You read it in class 6. What is a nebula? It's a
Ma'am, it is
cluster
a
of,
dust cloud.
huh?
Ma'am, it is like a dust cloud.
Cloud.
Yes, dust, clouds of dust, and it's a cluster of these dust clouds which are always floating, and that pattern, whatever they make, they refer to it as nebula. Clear? Now we take up weather and climate today. Now there's a very thin line difference between weather and climate. Let us see it. Climate is one of the basic elements in the natural environment. It affects landforms, soil types, and vegetation. It is it influence on a man is its influence on a man is very high. Our choice of clothes, food, and the house in which we live is initially related to climate. Now, before we go on to difference between climate and weather, we need to know what climate is. Now, people living in hilly regions, there, what type of a climate do you think it would be? Cool, okay? Or for that matter, people living near the poles, what type of a climate they would be? Huh? Poles पे warm होगा बेटा. Poles पर again it will be cool. It will be frozen. So when the living conditions are taken for a bigger, huger period of time, and they are taken for a longer duration, which affects the climate, the crops, the clothes we wear, the type of food we eat. All this is done and taken in the climate. Okay. Now, weather. What is weather? Today it's a sunny weather. Yes, for a short duration. And yesterday it was raining. Now, this weather changes which occur day to day, which are very randomly occurring, that is called a weather. Clear? Which is only for a short duration. Clear? Climate is for a longer period, the stability taken over the time. Clear? Like supposing we are having summers, we are switching over to winters. Clear? So we know that there's a weather, a climate change in our position of the earth. Clear? The place where we live. So that is climatic. Clear? But yesterday it rained and today it's sunny. These are weather changes. Did you get it? The day-to-day changes. Now I'll read out weather for you to make things more clear to you. The term climate should not be confused with weather. Weather is the day-to-day condition of the atmosphere at any place. Weather can change dramatically from day to day. A hot or humid weather may make one irritable. A pleasant breezy weather may make one cheerful. So, climate is generally defined as the average state of weather, whereas elements of both are the same, that is temperature, pressure, winds, humidity, rainfall, etc. That means both weather and climate. They take these factors into account. Temperature, the everyday, every time weather and climate both need it. Then rainfall, both need it. All these factors, pressure of the winds, etc., everything is needed by both climate as well as for weather. But then weather is the day-to-day occurrence and changes in the temperature and of a place or a places in accordance, whereas climate is a huge area covered which is experiencing a same kind of climatic conditions. You get it? What are you trying to do? Leave it. Leave this. Now we come on to temperature. Temperature is the term used to express the intensity or degree of heat in the atmosphere. Now temperature means कि एक particular atmosphere में कितनी गर्मी है उसका measurement is called temperature. Clear? गर्मी या cold, whether it is hot or cold, both is temperature, and the measurement is called the temperature. Clear? The measurement is of the heat or the cold is recorded under temperature. Okay, the sun is the primary source of heat for the earth, but the sun's rays do not heat the whole surface of the earth equally, owing to the earth's spherical shape and inclined axis. There is unequal distribution of solar energy. The amount of heat received at any place therefore depends mainly on the duration of sunlight and the angle at which the sun's rays strike the earth. So now we all know that the earth is slightly tilted. Supposing we take this as the equator and it is, instead of being straight, it is slightly tilted. Clear? Now the rays of the sun, supposing this is the sun and the rays is falling. So if the northern hemisphere is tilted towards the sun, that means the northern hemisphere will be having summers in those times, and the southern hemisphere will have winters. Clear? You remember last year, as I told you, when the earth keeps on rotating, revolving also, then it reaches a point when southern hemisphere is closer to the sunlight, then southern hemisphere will have summers, and since the northern hemisphere is tilted away from the sun, it will have winters. So the amount of rays falling on the earth while its axis is tilted in a position, that affects the temperature of a place. Clear? And that is why we know that temperature depends upon these two factors, the duration of sunlight. Now, on the poles, do we get the sunlight? When it is in the northern hemisphere, the north pole might get a little bit. Southern pole is completely dark. When the southern pole is tilted towards the sun, then southern pole will have the sunlight more, and the northern will be in total darkness. Clear? Because of the slanting rays reaching there, that is why the poles are cooler. Whereas at the equatorial belt, next to the equator, the torrid zone, you remember, the torrid zone where the sun rays are falling directly over the head. Those are the hottest places. Clear? So this is what they are telling you. Is this much understood by each? Okay. The amount of insolation or heat decrease from the equator towards the pole. Therefore, the temperature decreases in the same manner. That is why the poles are always covered with snow. Temperature in cities is much higher than that of villages. The concrete and metals used in buildings and the asphalt of roads get heated up during the day. This heat is released during the night. So they are telling you this also, that because of the equatorial belt, next to the equator, the rays are falling directly, so it is cooler, so it is hotter than the rays falling at the poles. Here, they are slanting, so they are less effective, and that is why poles are much cooler than the central portion of the earth. Then they are also telling you that cities are warmer than villages. Why? Because here the roads are constructed with cement and asphalt, etc. Plus the houses are pakka houses. So a lot of heat is absorbed by these city houses and city places. Then the villages, which are sparsely located and the population is less. So the city remains cool and warm and hot, whereas the village is much cooler compared to the cities. So temperature, you saw the variations. Yeah. Moving further, next is pressure. Okay. Now, air is a mixture of gases and thus it has its own weight. Air exerts pressure through its weight. Air pressure thus is defined as total weight of a mass of column of air above per unit area at sea level. So please understand this. Now, air around us has a certain amount of pressure. And if you really want to know what pressure is, just push your push your hands closer to your ear and then just suddenly remove it and keep doing it. Can you see the difference? This is the air pressure. Since air is not visible to us, we are not able to feel it. Why? Because air exerts pressure on our body. Okay? And since our body also has oxygen, it also exerts equal amount of pressure back. So the pressure is balanced. Clear? Clear? That is why we do not come to know about air pressure, but air has pressure. Okay?
Yes.
Okay. Air pressure thus can be defined as the call went on hold. Can you all hear me?
Yes, ma'am.
Okay. Sorry, there was some call. Okay. One can imagine as to how much weight of overlying air is being carried by every man daily, but he does not feel that enormous weight on his head and shoulders because of the air pressure inside human body exerts equal amount of outward pressure which balances the inward atmospheric pressure. There is inverse relationship between temperature and pressure. That is, if temperature increases, pressure decreases and vice versa. So now they are telling you that the air exerts pressure on us and we do not feel the amount of pressure we carry on us. Why? Because our body is also exerting back the same amount of pressure. Okay, so they have told one thing, that temperature and pressure, they go hand in hand. When temperature increases, pressure decreases. Let me tell you, जब टेम्परेचर बढ़ गया यानी कि गर्मी बढ़ गई तो एयर का प्रेशर कम हो गया. Why? Because the air gets heated up and heated air is lighter, so it turns upwards. Clear? So When the temperature increases, the pressure decreases. When temperature decreases, pressure increases. Clear? Clear? Okay. As we go up the layers of atmosphere, the pressure falls rapidly. The air pressure is higher at sea level and decreases with height. See, next to the sea level, the air pressure is very high. And as you go up, the air pressure decreases. Why? Because the air gets thinner and thinner. Clear? This is what they are telling you, that air pressure decreases with height. Now, horizontally, the distribution of air pressure is influenced by temperature of air at a given place. In areas where temperature is high, the air gets heated and rises. This creates a low pressure area. Now, जहाँ पर temperature increase हो गया, जहाँ बहुत गर्मी पड़ रही है, वहाँ की हवा जो है वो, I told you, it turns hot and it turns up, ऊपर की ओर बढ़ने लगती है. So here there is a low pressure area. Why? Because the temperature is high, so pressure will be low. So low pressure area हो जाता है. Clear? And the rest surrounding areas are high pressure. So wind always blows from high pressure to low pressure. तो जब बीच में आती है तो कभी देखा है वो जो बवंडर बन जाता है हवा का, that is because of that. Okay? Have you seen the spiral movement of the air? It is because of that, the low pressure area surrounded by all the high pressure areas, and this whirls up. Yeah? So this is what a beautiful example is of pressure, and air exerts pressure. Okay? Okay. In areas where temperature is high, the air gets heated and rises. This creates a low pressure area. In areas having low temperature, the air is cold and heavy, which creates high pressure areas. And I told you, if the temperature is low, that means if it is cold here, then the air or the pressure exerted by air would be intense. Okay? And it would be just the opposite of the temperature. Temperature high, pressure low. Temperature low, pressure. Yeah? The air always moves from high pressure area to low pressure area. As I told you, जहाँ low pressure area हो गया तो high pressure के जो area उससे सबूर से हवा आने लगी, so it formed a cyclone kind of a thing. Yeah? Next is wind, hava, most commonly heard. Yeah, let's see. Wind is the air in motion. Now, the air which is moving is called wind. Air is everywhere, but only when it is moving that you feel it. Just wag yourself up. Wag yourself up. Did you get the air? This is the wind. Yeah? When you are making the air move, it is the wind. Okay? Now, when the air is at rest compared to surrounding objects, we are scarcely aware of its presence. When the air is constant, when there is no breeze moving around, then we say, okay, it's normal. We do not notice it. But then air is present. Okay? But only when air is moving, we call it, oh, hawa chal rahi, wind. Okay? At times, wind wind can be so strong that it is difficult to walk against it, and it is also not easy to hold an umbrella on a windy day. You all must have seen when the wind blows to its extent. Like a few days back, it was so tremendously windy. You saw, along with the rain, a lot of stormy kind of wind it was. So it is very difficult to walk in those difficult times. Okay? And that is a windy day. Now, a wind is named according to the direction from which it blows. Now, winds, most of the time, if this is the earth, they are moving in a certain direction. Now, they are known for those directions and they are studied accordingly. Those are the fixed kind of winds which blow. Clear? We will read about them later. Okay? Now, thus, a wind from the south blowing towards the north is called a south wind. Now, supposing this is the North Pole, this is the South Pole. If a wind is going from south towards the north, it will be definitely called a south wind. Yeah? but it is blowing towards the north. Clear? So the winds, according to their directions, have been named accordingly. Then they are telling you winds can be broadly divided into three types. There are three types of winds. First is the permanent winds. Now these are the winds which we just now talked of. On the earth, whichever direction from which the wind is blowing, they blow constantly because the earth is spinning. So the wind which is blowing is in a particular direction throughout, always. So such winds are called permanent winds. They always blow. Like the south wind will always blow from south. Come what may. Okay. Let me read it out for you. Permanent winds. The winds, please backbones straight. Today I'm not finding the class very brightly listening to me. Yes, good. The winds blowing almost in the same direction throughout the year, they are called prevailing winds or permanent winds. So the other name of permanent winds is prevailing winds. That means they keep blowing throughout the year in the same direction. Yeah? Such winds are called permanent or prevailing winds. Now these are also called invariable or planetary winds. Please underline these two other names. So we have four names of this particular permanent winds, then come on, prevailing winds, then invariable winds, and planetary winds. All mean the same. Now, why they are called like this? Let us see. Because they involve large areas of the globe. Because they are a global winds. The whole globe, the earth, is occupied and covered by these winds. So that is why these winds include trade winds, westerlies, and polar winds. Trade winds, westerlies, and polar winds. Clear? So we'll talk about them further with the other two types in our next class. Okay? Thank you.
Thank you, ma'am. Bye, ma'am.